DataFrames support numeric indexing, which complements the label-based indexing that we saw in a previous lesson. This feature is used, for example, to select contiguous blocks of rows or observations with a fixed size. Using numeric indexing is simpler than using index labels, since there is no need to convert the integer position to the label when selecting. Numeric indexing uses iloc instead of loc, and is virtually identical to selection in NumPy arrays. The sole exception occurs when selecting both rows and columns with a list. DataFrame selection behaves as if np.ix is always used, and so toLists always select blocks of rows and columns. Start by opening Lesson 12's notebook in VS Code. Before attempting the problems in this lesson, we need to create some variables that we will use. Import NumPy and pandas. X is a 5x5 array, and we can create it using arange 25 and then calling reshape on the array with one argument, 5, 5. This parameter is the dimension of the array we wish to create. XDF is a plain pandas data frame that uses X as its data source. XNamed is a data frame that also uses X, but that adds columns C0, C1, C2, and C3, and an index containing R0, R1, R2, R3, and R4. Y is also created with an arange. It is one-dimensional, and so we do not need to call reshape. YS is a plain pandas series. YNamed is a pandas series that has an index added, R0, R1, R2, R3, and R4. This series is like a column from X. iloc is used to select using numeric indices. Numerical indices are often simpler to use than labels when the selection is inherently a fixed number of positions. For example, numerical selection is used when computing statistics over fixed-length windows of a time series. iloc can be used with one or two arguments in a data frame. It can only be used with one in a series. iloc accepts scalar integers, lists of integers, or slices. Like NumPy, selecting with scalars results in dimension reduction. When using a scalar integer, a data frame can return either a series or a scalar, and a series will always return a scalar. iloc and loc are closely related, and using iloc is equivalent to using loc with labels from the index or columns. If a data frame has both an integer index and integer column labels, then iloc and loc behave the same way. The first problem asks us to select a specific element. We can choose this element using iloc bracket 0, 2. The other element is also selected using iloc and 2, 0. We can take a look at XNamed to check that these are the correct elements. Selection in a series is identical, only using a single index. We can get the second element using iloc 1. Remember that Python is 0 indexed, and so the second element is in position 1. Row selection uses iloc that only specifies the rows to select. The column position is omitted. Here we get the second row using iloc 1. We could also have used iloc 1, colon, but trailing trivial slices are optional. This produces a series since we are using scalar selection in a data frame. The next problem asks us to select the same row, but to ensure that it remains a data frame. We can preserve the dimension using a slice 1, 2, which only selects row 1. If we use iloc followed by a list containing 1, bracket 1, close bracket, then we retain the original dimension and get a data frame with 1 row and 5 columns. Next, we select the second column. The first problem asks us to select a column as a series. We can do this using scalar selection with iloc, 1. The code in the video is incorrect. The annotation in the video has the correct code. Then, we select it while retaining the data frame structure. Since we are selecting columns, we include the trivial slice in the row's position. We can retain the data frame using a list containing 1. Note the double brackets in the answer. The outer is for the iloc operator, and the inner creates the list. If we use the same command without the list, so just iloc, 1, then the value returned is a series. This is expected, since scalar selection reduces dimension. Next, we use iloc along with a slice to select 2 columns. We start with a colon in the rows position. The slice 1, 3 select columns 1 and 2, but not 3, since the endpoint is not included in a slice. Next, we use iloc to select the second and fourth rows. We can use a slice with the optional third argument, step, to select 1 and 3. This slice ends with the largest value that is less than 4, which is obviously 3. The final argument tells the slice to use a step size of 2. Alternatively, using iloc with a list containing the values 1 and 3 selects the same rows. The only important difference between NumPy selection and using iloc occurs when selecting blocks in a data frame using lists. NumPy requires that we use np.ix to reshape lists when selecting rectangular blocks. DataFrame selection using toList behaves as if np.ix is always called. This simplifies block selection in data frames. We can select blocks using 2 lists of integers. We can select the second and fourth rows using a list with 1 and 3, and the second and third columns using a list containing 1 and 2. Notice that this selects a block. This is the one key difference with NumPy, which needs np.ix to select blocks using only lists of rows and columns. We can select the same block using only slices. 1, 4, 2 to select rows 1 and 3, and 1, 3 to select columns 1 and 2. Lists and slices can be mixed when selecting blocks. Here we can select the second and fourth rows using the list 1, 3, and the second and third columns with the slice 1, 3. Mixed selection is implemented using both loc and iloc. Here we use loc to select the columns C1 and C2, and iloc with a list containing 0, 2, and 4 to select the rows. We can select these in either order. Here we use iloc first, with a trivial slice for the rows and a list for the columns. Finally, we use loc with a list containing R1 and R2 to select the rows. Numeric selection in data frames is virtually identical to selection in NumPy arrays. Using iloc, elements can be selected using combinations of scalar integers, lists of integers, or slices. The most important difference occurs when selecting blocks of a data frame using two lists, which always selects all rows and columns in the two lists. This is equivalent to calling np.ix when using two lists to select a block in a NumPy array.